Hello guys, everybody, welcome back to another classic arcade repair. Here we have yet another computer space, if you can believe it. This is like, I don't know, the third one, and maybe the third one total, I don't know. Anyway, this one's super clean. I mean, this board cage is really super clean and nice. The board set on this one is peculiar because it's different. It's a different layout than my other ones that I've worked on. This board is a lot, it's not a lot different, but it is different. It's got different chips up here, and it's got some hackery there. But I think that's factory hackery. Okay, and then this board is different. The starboard or whatever is much different. It's basically a completely different layout. So, yeah. Interesting. And this board looks exactly the same, which it's got these old caps that'll have to be replaced. We know that. So that'll probably be the first thing we'll do. And then put it together. I'm starting to get my harness together. I've got this sheet out for wiring. Here we have the video and sound stuff, and yeah, so I'm just going to verify these because I was thinking that this was ground, and they've got this marked video and this marked ground, but I was convinced from doing previous repairs on these that the solid wires were the signal wires. I could be wrong though. I'll figure that out. I got my power wires hooked up. This is my AC for when I get there. I don't really need that right now, but I'll hook this up, my controls, and yeah, so we'll go from there. Let's get this thing all hooked up and see what it does. All right, I got my stuff hooked up. I got the board hooked up. I got my power monitored. I got 5 volts. These are not the best leads. Got it turned on, hooked up, and we get no motion characters, no motion board stuff. No bad guys, no nothing like that. Let's try firing this thing up and see if it does anything. This is coin and start. There's our guy, it looks like. Maybe. He's rotating, see that? Rotate left, but he does not thrust. He fires. He does not thrust. No movement. So no movement, I should say no thrust. He does rotate. Rotate left, rotate right, and he fires, but he does not thrust. And there's no there's no bad guys. So that's what we're dealing with. That's what we're starting with. So first thing I want to do is I want to replace the caps. because I know from experience in doing this, bad caps can kill motion, the motion circuitry. So yeah, so I'll do that first. And this is a nice clean set, really nice and clean. So let's go ahead and replace those and then see what we're working with. Alright, replaced all the capacitors. Here's the old ones, and there were two open 10 microfarad caps. Only two of them were open. The rest of them were okay. They were a little drifty, but they're not bad. These two are open. So yeah, I've got it recapped with new caps in it, and we'll see what difference that makes. That's got to make some kind of difference. Maybe that's our thrust, or who knows what that did. But those are just, I don't even bother checking what circuit they're in or anything like that. They just need to be replaced, period. So I got them replaced, and we'll hook it back up and see what we get. Yeah, these two open caps. Yeah, it's supposed to be 10, and they both read like that. So we got two of them that are open. Alright, let's hook it back up. Okay, we're hooked back up. Got my video and my power. And power monitor. Give it a fire up. Here's the new caps installed. Okay, still no bad guys on the screen. Let's go ahead and start. Here's our coin. Here's a start. Alright, there's our guy. Still no thrust. Thrust is actually working, but there's no movement. You see the little flame? Right now he's supposed to be moving. I can extinguish that flame. Now he's supposed to be moving. Now he's not. So that is actually working. This control is working. This is thrust. I just don't have a... the way you turn it off is you short it. See that? And then, yeah, so there's just no movement. Now it will, this is rotate right. So he rotates right and looks fine. I got the brightness a little too high. And we will rotate left and look fine. We can fire. And fire. Yeah. But there's just no bad guys. And we're counting. Counting seems to work correctly. You know what I need to do is I need to pay more attention to that this time. Turn the brightness down a little bit too. I'm going to turn the brightness down a touch, and I'm going to pay attention to this counting next time. I'm going to do that off camera. Just make sure this thing counts up to zeros proper, and it shuts off, your guy disappears. So that looks like it's working, but I want to do that off camera again. I'm just going to coin it up, and I'm going to watch it count and just make sure. And then we're going to work on the motion board, because that's where that's where our problems are at, on the motion board. Alright, so I've removed the top memory board, and I wanted to expose this motion board. And I know from memory this has 16, 4 times 4, 16 161 counters on this board, right, this block. So I got my probe out, my little scope, and I was just kind of probing around on these. I know what these are, and they're being sneaky and removed the numbering for these chips. But I know what these are. These are 161. So I got to looking at them. Okay, clock. Oh. I must have removed my ground. So you got clock. Okay, there's the clock. Clock, good. They're clocked. This row right here of 161s is not clocked. And these are all ganged. They're all connected. So it's got this row has the same clock. And I traced back that signal to right here. Pin 4 of this chip is floating. I don't know what this is. And it's only connected. This has got to be an output because it doesn't go anywhere else. It goes from here to this trace over to here, and then it's just a wire bus down to pin 2 of all of these guys, and that's all it does, I think, from what I could see. So this has to be like a LS75 or something, maybe. 1, 2, 3, 4, 5, 6, 7. No, it's a 7 pin. It's a 14 pin chip with pin 4 being an output. Could be an inverter. It's possibly an inverter. It looks like an inverter. Okay. Yeah, it looks like an inverter. 04. High. Low. Signal. Signal. Yeah, it looks like a 04. Darn it. There's that, and then that is its output. That out to this, and then this out to this. So it looks like it's a 04. So I think what I'm going to do is just jump a 04 over this and see if our ships show up or what. Alright, I don't know if you can see that. I just got an 04 jumped on there. And I put the memory board back on. And our ships are there. And they're moving. Hey! So let's actually fire it up. Let's go with a coin and a... There's our guy, and he's moving and rotating. Why is he rotating? Oh, he's not. Okay. There, now he is. Rotate, right. And if I turn off the gas, it's looking like it's working. Turn on the gas. And we got good collision detection. So I'll take it apart and I'll replace that chip proper, and then we'll test the sound out. Yeah, but that's what that was. That is a that's an inverter. So alright, let's get that replaced. Okay, and here we are. And as I've done on the previous computer space repairs that I've done, I replaced all of the decoupling, as those things have been proven on more than one occasion to be microscopically leaky, which means it's just an extra stress on the power supply that's not needed. So, put new decoupling in and replace that chip. Replaced some of the electrolytics that were left. These two, this one right here, and yeah, that's it. And all the caps in this chip. So let's put it back together and give it a shot. Alright, so I got my little 12-volt transformer hooked up. I got my sound amp hooked up, plugged in, ready to go. So let's fire it up. Sound amp is on. Game is on and working. I adjusted out that little curl at the top of the monitor. You just go into this test pattern like this and then straighten it out. It's just on the side here. Like I said, this is a really clean board set. So let's see if we got sound now. Let's coin and start. Okay. We're missing some sounds, it looks like. That's there. Rotate. The boom is there. Fire is missing. Rotate right sound. We should have like a buzz, like a doot, doot. Thrust is good. We need fire. We don't have fire. Okay. So we need to look for, we're missing two sounds I can tell. There's a really annoying like siren the whole time. It looks good though. The game looks really good. I need to get this to where I can turn this off. Thrust. I don't like that. I need another switch. But yeah. So we're missing the background buzz, and we're missing fire. I think enemy and regular ship fire. So I'll have to get the schematic out. That's on this board, I think. Possibly. So yeah, we'll figure it out. Get those two sounds. Our rotate sound is good. Thrust is good. And I think that's really all we got. So we'll have to figure out these sounds. No problem. Let's get to it. I'm going to have to get the schematic out. Okay, I was looking at the missile sound circuit, and it's a little interesting. Here it says missile sound. You see that? Missile sound. That's an output. And then up here we have another missile sound output. Alright? It's the same circuit basically. It's an output through a 0.2 microfarad cap and a 1K resistor, and it's missile sound. It's the same thing down here. It's an output through a 0.2 microfarad cap, a 1K resistor, missile sound. Now these are generated differently. This one way up here is generated through the switch, missile fire switch. And you can see when that goes high, it activates this and sends a high out this way and causes that output to go low, and that's what activates that sound. And then this one is an automatically generated right here is a oscillator. Okay, it's VCC out here, and it just oscillates. It creates an oscillation. And if I see, here's the side of that. I'm sorry about this camera work. And that causes this to pulse, and yeah, causes this to pulse, and then this pulses here, and then this pulses at a set interval. This counter is for the saucers, I'm sure, and at a given count this will pulse, and this saying that both of these need to be low to get the desired output of a 1 here. And it'll just create a pulse here. So that's how that one works. Yeah, interesting. It's like this one is working on a low pulse. You got two highs making a low there, and then here it's opposite. You're getting two lows to make a high pulse here, and that's probably just the tone difference, as this is for the saucers shooting, and it's a higher tone than when you shoot. It's a lower tone. Anyway, those two tones go together. Missile sound. These two missile sound are basically, they're put together. They're sent together to right here. Missile sound. So you have a series of highs and lows. So it probably is at a floating level, and it drives low or it drives high, and that is going to change the tone. And here's the turn sound. So what this basically is telling me, we have the turn sound. So this circuitry has to be okay, because this turn is getting through here. So either both of these are bad, either both of our sound circuits for the missile are bad and they're not doing anything, or this resistor could be bad, right? But chances are, even though it is possible, chances are both of those circuits are not bad. I'm leaning towards checking this resistor, because this is getting through, but this is not having any effect, this sound. And this is actually two combined signals right here. So there's two missile sounds right there. Two sources, I should say, going into the same input here. And for whatever reason, we have nothing here. But this is getting through. See, I'll go ahead and fire this thing up. I got this thing out just in case I wanted to probe. We'll turn it on and wait for it to come up. And you know, the flying saucers fly around and they shoot at a interval, at a predetermined interval based on those counters on that other page. And your rocket missile is determined by the fire switch. So when we turn it on, you'll see the saucers shoot every however many counts those counters are counting. At a certain interval, it'll shoot. So that's when we should be getting the higher tone beep. But we're not getting anything, so we'll go ahead and fire it up. Coin. And you see the saucers are shooting every so often. So that circuit's working. And the fact that the circuit is working and it's actually firing tells me that the pulses are there. When I fire my rocket there, see? When my ship fires, it works. You see the bullet, but there's no sound. Now if we rotate, see, we got the rotate sound. It looks perfect, by the way. It looks absolutely perfect. And then rotate the other way. Yeah, so our rotating is working. Our counting is working good too. Our rotate sound is working, so that tells me, here's the turn sound. The turn sound is getting through here. This one is not. Even though the missiles are firing, nothing's happening here. So I'm going to check this 47K resistor. Both of these. You have two 47K resistors here where these sounds come in. So I'm going to start right there. Okay, so I've got this here. And I have found the two, I'm going to turn this off. I've found the two 47K resistors. And if I look at them, this is one of them. $47.3K. And then here's the other one. And that one is 44.7K. I think that, yeah, okay. Alright, so that looks good. And where's my probe? With it turned off, I just want to look at this. Oh, it ain't gonna. That don't make no sense. All right, I'm gonna turn it on. Okay. You know what I want to do? Here, let me grab this. And what I'm doing here now is probing, and this is one of the inputs. This is one of those 47K inputs. Oops. So I would imagine that this is probably I don't know. I guess I have to remove this board and get to that motion board, because that's where those signals are created, and check those chips and see what's going on. One of them might be stuck low or stuck high or something like that, and is messing the whole thing up. So let me go ahead and check into that. Well, goodness gracious. Missing a cap right there. And we're missing 2 caps down here. Here and over here. I forgot to put some of the caps back in, guys. Goodness, I bet you that's the whole problem. Is the signals are just not getting... Remember, there's capacitors they go through. Remember, these signals both go through a 0.2 microfarad cap. And you know why I left these out? I left these capacitors out because I put in the decoupling, I put all 0.1 microfarad caps for decoupling. But if a cap looked like it was in a signal, an actual signal path, a signal path, I did not put 0.1s in because I was going to put a 0.22 in. And I bet you those are those. I bet you they're both down here. This one might actually be decoupling. But I'm going to put a 0.22 in there, and then a 22 here and here. And I bet you those sounds come right back. So let's go ahead and do that. My bad. Yeah, guys, remember they went through 0.2 microfarad capacitors and then 1K resistors. There's the 1K resistors, and these are the 0.22 microfarad caps that I had forgot to put back in. So yeah, that's gonna fix our sound. Yeah, my bad. All right, we're back together. We're looking good, and we can coin up. There it is. There it is. Got him. Jerks. Oh, quit shooting me. Got him. Yeah. And it is counting, right? Is those the two count numbers are only single digit. Yeah. And yeah, let's do one more game. I'm going to put the camera on the tripod this time. Turn off the lights and see how cool it looks. All right, here we go. Coin up. Start. Darn it. Alright. Pretty cool in the dark, ain't it? Yeah, I didn't really have the whole screen in there. Let's try this one more game. Like that. Alright, here we go. Someone's knocking on my shop door. Alright, you get the picture. You get the point, right? And game over. Oh, that's it. So yeah, it works perfect. It looks good. I'm gonna, well, let me come back. We'll talk about everything I did here. All right, Saturday night, my friend Todd just stopped by and chatted for a little bit.
Todd's cool.
He was the one knocking on the door. But, yeah, he borrowed my deoxit. He came and borrowed my deoxit and stuff, and I just brought it back, dropped it off. But I am actually running this now on my power supply. You can see it's right at 3 amps. So it's running, pulling 3 amps, and it's actually, you know, 4.93. So this thing stock has a 3 amp power supply, and this is the most it would put out is 3 amps, and you're at 4.9 volts basically. So that's pretty much the ceiling of the 3 amp power supply. If it doesn't put out any more than 3 amps, and it may be able to handle 3.5 amps. I don't know exactly, but anything really more than that, it's really going to hurt the performance of that thing. Now, if you recall, the first computer space repair that I did, I actually replaced a bunch of the parts. I replaced a ton of parts with low power parts, LS series parts. And I remember that one pulled 1.85 amps at 5 volts on the board. So yeah, these can really benefit from LS parts. It really does help the power consumption. Anyway, I just wanted to see how it was doing as far as the draw. And it's right at 3 amps at 5 volts. So, yeah. I guess the only thing for me to do is to let this thing run. It's working perfect. It looks perfect. So I'm going to hook the power supply, that one back up. And I'm going to let this thing run for about 3 hours. And that'll do it, guys. Thanks for watching. Yeah, and we replaced all of these capacitors. All of the decoupling has been replaced. Once again. All right. We'll see you all on the next Classic Arcade Repair. Shout out to all the channel members and Patreon members. Appreciate you all, as always. And don't forget to check the item description of the video below for all of your electronics repair and bench supply needs. I've done the hard work for you, and I've compiled a huge list of everything you could need. So you can go there and easily just click on the link and it'll take you right to whatever you need. So, alright guys, we'll see you all on the next Classic Arcade Repair. Bye for now.